Have you ever wondered about the beginning of everything? We've all been told the story. 13.8 billion years ago, our universe exploded into existence from a single, hot, dense point. This is the Big Bang. But what if I told you that this beginning, this very first moment, might be scientifically impossible? This isn't just some wild idea. Neil Turok, a leading cosmologist and director of the Perimeter Institute, has said that the standard model of cosmology starts with an impossibility. So, what is this impossibility? It's something called a singularity. Let's break it down. A singularity is a point where all the known laws of physics just stop. Imagine cramming the entire universe into a space smaller than an atom. Density becomes infinite. Time and space lose their meaning. It's a mathematical black hole that science can't explain. The Big Bang theory says our universe began from this very point. It's like starting a story with a sentence that makes no sense. But that's not the only issue. The Big Bang model has other major headaches. First, there's the horizon problem. When we look at the universe, it's incredibly uniform. The temperature of space is almost exactly the same in every direction. But here's the puzzle. According to the Big Bang, opposite ends of the early universe were so far apart, they could never have been in contact. They were outside each other's horizon, or communication range. So how did they all end up at the same temperature? It's like finding two people on opposite sides of the Earth who have never met or spoken, wearing the exact same perfectly matching outfit. It's statistically baffling. Then there's the flatness problem. Our universe is remarkably, almost perfectly flat. Think of it like this. If the universe had even a tiny bit more energy density, it would have collapsed back on itself long ago. A tiny bit less, and it would have expanded so fast that galaxies could never have formed. The initial conditions had to be fine-tuned to an absurdly precise degree. The Big Bang model offers no reason for this incredible flatness. It just assumes we got unbelievably lucky. So we have a theory that starts with a physical impossibility and requires two massive coincidences to work. This has led many physicists to ask a radical question. What if the problem isn't in the details but with the idea of a beginning itself? What if there was no beginning? This is where a mind-bending new idea comes in. The Big Bounce. Imagine our universe wasn't born from an explosion out of nothing, but from the collapse and rebound of a previous universe. Not a Big Bang, but a big bounce. Look at these two models side by side. The Big Bang starts from that problematic singularity. The Big Bounce, however, shows a contracting universe reaching a minimum size and then bouncing back, creating our expanding universe. The difference is profound. So does this idea solve the puzzles we talked about? Let's see. Remember the horizon problem? How did the universe become so uniform? Well, in a Big Bounce scenario, the previous contracting universe had billions upon billions of years to smooth itself out. Every corner had plenty of time to mix and mingle, like stirring cream into coffee until it's all one color. When it bounced, this uniformity was already locked in. Problem solved, naturally. What about the flatness problem? The same contracting phase takes care of that too. As the previous universe shrank over eons, any curves or wrinkles in spacetime would have been ironed out, a process physicists call superflattening. So, our universe isn't flat by luck. It's flat because the contracting phase made it that way. Another puzzle solved, no fine-tuning required. But this brings us to the biggest question of all. If a previous universe was collapsing, what stopped it from crushing itself back into that dreaded singularity? Why did it bounce instead of just ending? The answer lies in the weird and wonderful world of quantum mechanics. As the universe contracts to a size smaller than an atom, classical physics breaks down. At this incredibly tiny scale, a powerful repulsive force, a kind of quantum pressure, kicks in. This force is so strong that it resists the final collapse, halting the contraction and forcing the universe to rebound outwards with incredible energy. That rebound is what we perceive as our Big Bang. So the singularity, the impossible beginning, simply never happens. It's replaced by a bounce governed by the laws of quantum physics. Now, the Big Bounce isn't just one single theory. It's a whole field of cutting-edge research with different versions or flavors. There's the ekpyrotic model, which comes from string theory and suggests our universe was formed from the collision of two brains in a higher dimension. Then there's loop quantum cosmology, which proposes that space-time itself is made of tiny, indivisible loops. When the universe contracts, these loops can't be compressed beyond a certain point, causing the bounce. All these theories are different, but they all point to the same incredible conclusion. Our Big Bang might have been a big bounce. You might have heard of another idea called inflation, which is an add-on to the Big Bang theory. Inflation also solves the horizon and flatness problems by proposing a moment of hyperfast expansion right after the Big Bang. But it still doesn't get rid of the initial singularity. The Big Bounce, on the other hand, solves all three problems by eliminating the singularity from the very start. And this isn't just philosophy. These are testable scientific hypotheses. Scientists are currently scanning the cosmic microwave background, the oldest light in the universe, for tiny temperature fluctuations. Different models, like inflation and the various Big Bounce scenarios, predict different patterns in this ancient light. By studying these patterns, we might one day find the evidence that tells us which story is true. The implications are truly staggering. If the Big Bounce is correct, it means our universe is not the first and it may not be the last. We could be living in just one cycle of an eternal cosmic dance. A universe that contracts, bounces, expands, and one day perhaps will contract all over again. Our existence might be just one chapter in an endless book. It's a thought that completely reframes our place in the cosmos. What do you think? Are we the product of a singular one-time explosion or part of a timeless cyclical universe? Let me know your thoughts in the comments below. Thank you so much for joining me on this cosmic journey. If you enjoyed this exploration and want to dive into more mind-bending science, make sure to hit that like button and subscribe for more videos. See you next time.